Hey, fellow mathers! Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over 6K worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians! Welcome to the podcast where math is figureoutable. I'm Pam.
And I'm Kim.
And we make the case that mathematizing is not about mimicking steps or memorizing facts, but it's about thinking and reasoning, about creating and using mental relationships. Y'all, we take the strong stance that not only are algorithms not particularly helpful in teaching, but that mimicking algorithms actually keeps students from being the mathematicians they can be. We answer the question, if you're not teaching algorithms and step-by-step procedures, then what are you?
Yeah, so last week we started the conversation around addition facts.
Mm-hmm.
And we mentioned some really important ideas about speed, conceptual understanding, and fluency. And we also know that although we're talking about something that we wish younger grade students have a great handle on, we are all very aware, right, that we have some older students who still need experience with addition facts.
Yep.
So we want to invite all grade level teachers and leaders to join in today as we share about patterns with addition facts. These patterns are relationships that we want students to identify, explore, play with, and eventually own.
Yeah, it's going to be important that the way we learn the addition facts, the way that we automatize them, because we absolutely want students to know their facts, not memorize their facts, but to know them, to own them down deep inside. So before we get into tons of patterns, the first thing that I want to talk about today is the fact that we need students to understand what addition actually is. And it needs to be connected to experience, to sort of some concrete things. Now, this is a little different than just CRA. So listen carefully. You might be like right now going, oh yeah, it's CRA. That's what she's talking about. Concrete representational abstract or concrete pictorial abstract. So I'm actually not. What I mean here is, and I think many, if not most teachers today are aware of the fact that we don't start with students by saying, okay, lovely young students, here is 3 + 5 equals, now you do it. Because I personally know people who looked at that equation as a young student and said, 3 what? + 5 what? Like, what is this? And literally had no sort of context or meaning behind those symbols. And so we need to make sure that we do things with students where we just give them problems to solve that aren't necessarily represented symbolically. We literally just say, hey, I got 5, now pick something, markers and 7 markers. How many total markers do I have? Or, whoa, I had 8 markers and you just took 3 of my markers. How many markers do I have left? Like, we just throw out these problems and we let students solve them with concrete materials, and we let them sort of fuss with them. And we then represent what they're doing using more symbolic kinds of things. Like, we're like, oh, when you did that, that could look like this on paper. Like, when I just gave you that problem, it could look like, so for example, when I said I had 5, now I already forgot what I had, 5 markers, and you gave me 7 more markers. How many markers do we have? I could represent that with, ooh, this is a 5. And then I gave you, and I put the addition. So you can't see me. I'm just realizing I'm on a podcast. So I wrote the number 5 in the air, and then I gave you 7 more markers. And so then I wrote the addition sign, the addition symbol. And then there's a 7, and I wrote the 7. So the gave is sort of the addition symbol. And now I've got 7. I write the 7. And I'm like, how many total is that? And then I might write the equal sign at some point to when we've got sort of those 12 total. And then I might write, oh, and you told me there were 12. So I'm going to sort of represent the problem itself using symbols. Now you might be like, Pam, nobody looks at 5 plus 7 and says, what are you talking about? Well, I married him. And my husband can remember the days of sitting in first and second grade and looking at these symbols on a paper and having no idea what they meant. And realizing later in life, now not too much later, like third grade, oh, like you meant 5 paper clips plus 7 paper clips. That's what well, I could have done that.
Yeah.
Now don't look down on my husband. Plenty of people were here, but he literally thought that he was supposed to, it was like a puzzle that he was supposed to memorize. So this symbol plus that symbol. And sometimes he said, Pam, I even thought that like 5 plus 7 should be 5 and then a 7. Like you're putting them together, like 57. Like you're putting 5 plus 7 together. I mean, he was trying to make sense of what was happening. And because there was so little experience attached to the symbols, then he was having a hard time with that. So just right off the bat, won't talk too much more about it, but we need to make sure that we give kids experience. Kim, you and I have had experience doing this with young learners where we might do something like, hey, let's say we've got red and green apples. Now, we could choose any kind of total, but I'll choose 10 because 10 is kind of a cool total. We could say, if I have 10 apples, how many green ones do I have? And how many red apples do I have? Mm-hmm. And then let kids go. Mm-hmm. This is a super nice, open, rich task for young students to tackle because we can have students that just start guessing. They can start pulling out some red apples and green apples and kind of like, oh, here's some green, here's some red. Is that 10? Nope. Try again. We've even seen like they'll put them all back and then grab, oh, okay, how about these number of red? They're not even really like judiciously like taking away a green or red or adding more in, or, you know, like, oh, I only had 9. Maybe I better get some more. But we can sort of then step in as the teacher and go, well, I noticed when you had those 3 red and 6 green that you only had 9. But how many are we looking for? 10. Do you need more apples? Do you need less apples? We start asking those questions to help kids kind of get more clear, you know, if they're kind of haphazardly doing stuff. But we can have all the way to, we might have some students in that same exact class where we can ask, hey, do you have them all? Do you have all the combinations? You have all the number of red apples and green apples. For example, I see that you have 6 and 3, 6 green and 3 red. Do you have 6 red and 3 green? Do you have, well, I see that you have 5 and 5. Do you also have, did I just say 6 and 3?
You did.
Sorry, 6 and 4. How many apples are we dealing with, Pam? I'm alive. I'm awake. I slept last night. Sorry, 6 and 4, and then 5 and 5. And we might have a kid go, I'm done. I did it all. And you're like, well, I don't know. Your friend over here had 8 green apples. Is that a possibility? Could you have 8 green apples? Could you have some red apples to make? Do you think you have them all now? How do you know you have all the combinations? Bam! I mean, that is a great extension question that could keep many kids thinking for quite a while they might be helping students that are still making sense of, you know, any kind of combinations that are reaching 10.
Right.
So we really like that. In fact, I'm going to give Kathy Fosno credit for first introducing that task to me. We've used it lots with students, kind of made it our own in some ways, but that could be a way. That's an example of helping students really understand what we mean when they're later going to deal with these single digit addition facts. Oh, it's like these, all the ways that we made 10 apples, not 9 apples, Pam, 10. Oh my goodness.
One of the things that I love about that, you mentioned that there's access for so many different experience levels that kids can also do that task without having a lot of notation work, right? They can fill out a chart of 2, 8, 7, 3. And then it gives you an opportunity to introduce the plus sign or an equal sign, right? After they've already done some work messing and figuring about the apples.
Oh, really nice. In fact, I'm going to back up from that. You could even just have them draw red apples and green apples, and you could underneath that write the numerals.
Sure.
And then later introduce the plus symbol and the equals. It's very nice. Very nice. Yeah, I like it. Let's now talk about some of these patterns that can help kids automatize the facts. If we can help kids identify and explore and play with some specific patterns, then the facts start to make sense. And it's not just what I think some of us think, if I go to the store and I buy a deck of cards, addition flashcards. Here's my
Right.
deck.
Yep.
I mean, it's a pretty thick old deck, right?
Daunting.
And it could be quite daunting. And
Yep.
we might have parents that go, "Oh my gosh, my kid has to learn all of these,"
Yep.
and learn might feel like rote memorize, and that could feel very daunting. So
Right.
if we can look at some patterns and go, well, actually, there's whole sets of cards that we can
Right.
like, I understand these. I don't need to even think about these. I could just like do them, or I can just, I know these. We kind of set those aside and work on maybe the more difficult facts and how we could think about relationships for those.
So one of the things that I have a lot of experience with is that as a third grade teacher, we did this with multiplication, but it's absolutely true for addition as well, that when you connect the commutative property to the facts, right? You help kids make sense of the commutative property, then all of a sudden half that card deck or half of the facts on the addition table instantly goes away, right? So if you're looking at an addition table, there's this diagonal line that you can cut the facts in half. Or if you have a deck of cards that have, 100 facts, then once kids make sense of the fact that it is 7 plus 2, and that's going to give you the same total as 2 plus 7, then instantly, right, half the facts are gone. And you can connect that so early on, even with the rich apple task, because you're going to have 3 red apples and 7 green apples, and 7 red apples and 3 green apples. And if you focus on the fact that you still have the total of 10, then they can start to see that 3 plus 7 and 7 plus 3 still give you 10.
Still have the same total, which is the commutative property that one number plus A plus B is equivalent to B plus A. We get the same total. Nicely done. A nice connection back to the apple task. I like that. Yeah. So we like to do this with with parents sometimes. When we talk to parents and we're like, hey, they're like, how do you want to help your kid? Well, one way is to help them with their addition facts. And we're going to send a flashcard deck home with you. Now, we'll talk a little bit more about what that looks like in another episode coming up soon. So keep listening. But when we do that, we help parents understand. But check it out. Like, let's work on this idea that 2 plus 5 is equivalent to 5 plus 2. And bam, like we really only have to think about half of the deck if we can sort of use the commutative property to think about facts. So very nice. It's a great place to start. Let's also talk about a pattern in the addition facts with anything plus 0. So that might seem like the easiest one. You might be like, well, Pam, 3 plus 0, I mean, that's just 3. And 8 plus 0 plus 8, that's just 8. Right. But we do need to take into account that 0 was actually created or invented or established fairly late in our history. We had other mathematical concepts and numerals and things happening before we kind of came up with this idea of that we needed to represent 0, an amount of 0. So that can actually be a little tricky for kids. That's why we do problems like the apple problem, because in that list, in fact, we should have probably asked you guys before I just said that, y'all, if you're looking at that apple problem and I said to you, do you have them all? Did you include 0 red apples and 10 green apples? Or 10 red apples and 0 green apples? Like, did you include sort of this idea of having 10 plus 0 still being 10 apples? And if you have, then right here and now, when a student sees an addition fact like 5 plus 0, they can be like, oh yeah, like that. Meanie, you didn't give me any more apples. All right, looks like I just have the 5 apples I started with. And they can sort of make sense of that plus 0. But now that we've made sense of plus 0, bam, those are out of the deck. Like we can sort of take them out of the deck and we can move on and deal with other patterns. Let's talk about another pattern in the addition facts. What about plus 1 or even plus 2? So for example, if I look at 9 plus 1 or 13 plus 1, I mean, even 56 plus 1, don't memorize anything plus 1. Don't rote memorize that. That's not a fact you need to memorize. Just think about it. Like, just do it. Just like 56, 57, that's 56 plus 1 is 57. Just think about the next number in the sequence. Or plus 2, just add on 2. And I'm totally okay if kids count at that point. So instead of saying, all right, 5 plus 2, you got to memorize it. 5 plus 2 is like your shoe in the door. And so it's 4. Wait, not 4. I mean, I was trying to come up with a rhyme off the bat. Like, instead of trying to come up with something to help the kid memorize it, just think about what it means and just do 5 plus 2. Oh, okay, 5, 6, 7. Bam, I've got 7. And that takes the pressure off all of those +1s and +2s. And we can just sort of think about those as kind of the just do it facts. And we can take them out of the deck. Bam!
So I'm going to interrupt you here for a second because I can hear some of your listeners saying, wait a second. Isn't that going to get kids stuck in the counting domain of the development of mathematical reasoning? Right?
Wow, nicely done.
Forward.
Yeah. So if anybody's been listening and you've been thinking about the development of mathematical reasoning, and we're talking about not leaving kids in counting, but helping them gain additive thinking, this is one of those times where it's okay to count. Yeah. It just take the pressure off of memorizing those facts. Let them count the 1 and the 2. Now, after that, maybe I just said again, like you knew it was in my head. So let me say it for the first time so I can say again. If a student just knows 5 + 2, which often they do,
right,
we're okay with that. We're not saying thou shalt go count 5, 6, 7. No. If they know 5 and 2 and they just say 7, we're that. Yay, good. That's a good thing. This is only if they don't know it. If they don't just, like if I say 4 + 3 and they don't just pop out with 7, then in that case, I just did 3, 4 + 2. In that case, then I'm okay with them going 4, 5, 6. They're going to do that quick enough. It's not going to bog them down. After that, 4 + 3, now I'm going to want to work on some other relationships to help them sort of automatize those facts. I don't really want kids counting plus more than 1 or 2.
So it's interesting that we talk about these patterns and these relationships, that there's also some things that are happening simultaneously, that when you work on this count on fact, and you've also had this conversation and these experiences with the commutative property, then you also are working on counting on from the larger number, right? That's not something that we kind of parsed out, but I definitely want to. When you have the problem 5 + 2 or 2 + 5, if you have a kid that needs to count 5, 6, 7, you're okay with that. But we're not okay with somebody starting with 2 and saying, well, there's a 2 in the problem, so it must be 2, 3, 4, 5, 6, 7, right? At that point, what we would want them to do is say, okay, I see that it's 2 + 5. I'm going to flip that. I'm going to use a commutative property in my head, and I'm going to say that's the same as 5 + 2. So 5, 6, 7. There's a lot going on there. There's a lot of thinking. I had a student once, a group of teachers that were puzzled by the student who, for whatever reason, would not start from a larger number. Would not. If the problem was given to him like 5 + 2, then he would say 5, 6, 7. But if the problem was 2 + 5, then he would not. And I worked with him for a little bit.
He would start at 2 and count.
He would start at 2. Yep. Whatever the problem was, how it was written would be the way that he.
Thou shalt do it in order.
He would do it in order.
Yep.
And so I was intrigued and I wanted to know why. And so what I found, I did some work with him. And what I found was that he didn't trust the commutative property. So he thought, like, he was surprised to know that they were going to give him the same answer. He was okay with that, but he didn't trust it. And so when he was given a problem like 2 + 5 and teachers just said, oh, it's going to be the same, just flip it around, or what else would that be? Then he wanted to start in the order that the problem was given. And so we did some activities. We pulled out a rec and rec. We built 5 + 2. We flipped it upside down, saw that it was the same as 2 + 5. And he, did some activities.
Wait. Tell me, what do you mean by flipped it upside down?
So
what? The problem?
Flipped the rec and rec, the actual rec and rec, flipped it upside down. So
So tell me what it looked like first.
So if he had the problem 2 + 5, then we would move 2 beads over on the top.
Okay.
And 5 beads over on the bottom, so that it represented 2 on top, 5 on bottom.
Okay.
And we wrote that down, 2 + 5. And then he literally took the rec and rec and flipped it over so that now it had 5 on top and 2 on bottom, with no beads moving in either direction. They
just literally
just flipped it upside down.
Yeah, upside down.
And so we spent some time working with it. Is it going to always be true that when you flip the rec and rec over, no beads were exchanged in any way? And with some experience doing that, then he started to trust that he was going to get the same total.
Isn't that fascinating?
Yeah, it was really interesting.
I love it.
Right.
And how brilliant that y'all were willing to hang with him and deal with him and not just go, dude, Do it.
Yeah.
It's this.
Yep.
Like, make it happen. Like, you worked with him and talked to him. I love the flipping the rack and rack ups. That's pretty cool. Number rack upside down. Nice. Y'all, these are important patterns that we can identify, explore, play with, and eventually own. So important.
Yeah. And when you say eventually own, it's not magic, right? It's not going to just magically happen. Sometimes people will say, well, hey, I've heard you talk about this. And so I played that game that you mentioned, or we kind of walked through some patterns on the addition table and they kind of see what we're talking about it. We're suggesting that kids need repetition, right? They need lots of experience. It's just not the flashcards that we did when we were kids.
Yeah, what we're not suggesting is that you just rote. It's just like, we're going to rote drill you over and over and over. Not that, but lots of experience with Apple type problems. Lots of experience with having the kids tell you their reasoning for the facts and how they know it and what it looks like on a number rack, and then playing games where we expect them to spit back facts. But it's in an atmosphere where it's not about rote memory and it's not about speed.
Yeah.
And to be clear, earlier when I said, okay, so if you know +1 and +2, then you can just take those cards out of the deck. If you know +0, you can take it out of the deck. When I say that, I kind of mean take it out of the, okay, now we need to drill a kid on these. But I don't mean that we never experience them again. Like, I want kids to see 5 + 0 and to see 2 + 5 and think about 5 + 2 in that case. I want them to see all of, when I say take them out of the deck, I don't mean don't have experience with them again. I just mean don't fuss with them again. Now let's go on and explore other relationships. But I do want to have those problems come up all the time. So students deal with them over and over and over again. And that will help them as they use relationships to figure them out. That will help them automatize them so that they are less bogged down every time they see them after that.
Yeah. Join us next week as we continue to parse out patterns with the addition facts that can help students automatize the facts. So right now, Pamela, we have the You Can Change math class happening.
Woo!
That challenge is going on right now. It is so fantastic. We have the most amazing teachers and leaders joining us. And it's
totally one of the funnest things I do all year.
Yeah, we love it, love it, love it. And it's not too late to join us. So join us for the challenge each evening. You can register at mathisfigureoutable.com/change. We're also super excited because this Friday is open registration for some fabulous workshops written by somebody we love.
Bam!
They are happening right now. This Friday, you can register.
Yeah, and y'all, we have 4 super workshops I'm really, really excited about and proud of. Building addition for young learners, building powerful multiplication, building powerful division, and building powerful proportional reasoning. They are my pride and joy. I am thrilled with what we were able to create for y'all to learn more real math, take a deep dive into content, whatever content really fits for you. You can register for those at mathisfigureoutable.com/workshops. Y'all, if you're listening to this podcast at a time where registration isn't open, you can still go to mathisfigureoutable.com/workshops and get on the wait list. And we will notify you the next time that we open registration. Also, we'll be doing challenges. So get on the wait list for the workshops, get on the email list, and then you'll know the next time that we do a challenge if you happen to be listening to the podcast when we're not doing a challenge or when registration for workshops isn't open. So if you want to learn more mathematics and refine your math teaching so that you and students are mathematizing more and more, then join the Math is Figureoutable movement and help us spread the word that math is figureoutable. Thank you for listening and making math more figureoutable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figureoutable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.